So this video is called Systems of Linear Inequalities, and what we're going to do is we're going to graph these inequalities and then find where the shaded region should be. So let's get into this. I'm going to graph this first one using a red pen. And so it's y is greater than or equal to 2x plus 1. So y-intercept is 1, slope is 2. I'm just going to make some dots so I can connect these dots. There we go. And it's greater than or equal to, so that means I'm going to have a solid line because it's or equal to. And then greater than, that means I'm going to shade above. And so I'm just going to draw some arrows here. Actually, you know what? I take that back. I'm going to use my highlighter. Let's do that. And I'm going to shade above this line. And once again, if you're not sure where to shade, just pick a point on either side of the line, plug it in, and then see if it's true or false. If I tried that, just to kind of show you what I mean, let's say I picked this point right here. That is 0, 1, 2, 3, 4, 5, 6. That's 0, 6. That means is 6 greater than or equal to 2 times 0 plus 1. And 6 is greater than 1, so that one would be in the shaded region. So that's another way to check it out. Okay, and then I'm going to graph the other one using blue. So this has a y-intercept of 4, 1, 2, 3, 4, and a slope of -1. And so I'll just graph a bunch of dots here, and this one is less than, so that means I'm going to do a dotted line, not a solid line. And this one says I'm going to shade below. So let me grab my highlighter and I'm going to shade below this line. So there we go. So the shaded region, the solution to this system is where the shading overlaps. You can kind of see how I have that note here. It's where the shading overlaps. So the solution to this is everything in this shaded area that I'm shading right now with the yellow. I don't know if I really like that one. Let's shade it with green as well. There we go. So this green shaded section is all of the solutions that make both of these true. And so one way to check that is let's just pick a point in there, and let's do this point right here. So -1, 2, 3, 4, 5, -5, 3. And let's plug that into both of them and see if that is a solution. So I'm going to get rid of this, maybe. There we go. So let's plug -5, 3 in there. So that means we're going to have 3 is greater than or equal to 2 times -5 plus 1. Is 3 greater than -9? Yes, so that one checks out. And then let's do the same thing here. 3 is less than -5 plus 4. That is 3 is less than 9, and that one also checks out. So that's one way to make sure that you did your shading properly as well. Okay, then a question might come up is, are these points solutions to the given system? So 0, 0, if I look and I zoom in here, 0, 0 is not included in that overlapping area, so that would be a no. -1, -1, that would be right here. And that one is a yes because it is right on the boundary, and that boundary is a solid line. So that one would be a yes, and I'll show you algebraically why it is a yes in a moment here. 2, 0 would be right here, and that's in the blue shaded area, but it's not in the overlapping area, so that one is a no. And what about -1, 5? So -1, 5 is right here, and that one is right on the boundary line, but it's a dotted line, so that would be a no. With the dotted lines, those are not included, so this one would also be a no. So let me show you why these are no's and yeses using those two inequalities. And I have them down here at the bottom. So if we put 0, 0 in, that'd be 0 is greater than or equal to 2 times 0 plus 1. So that's 0 is greater than or equal to 1, and that's false. So if you get any falses, then it's a no. If you get both trues, then it's a yes, and we'll see that here on this next one. So let's plug -1 in. We've got, and -1 in, excuse me. -1 is greater than or equal to 2 times -1 plus 1. So that's going to be -1 is greater than or equal to -1. And that's true, because -1 is equal to -1. So now we have to test the other one. So we didn't have to test the other one on the first one because we got a false, so we don't have to test the second inequality. So let's test that one. -1 is less than -1 plus 4. So that would be -1 is less than 5, and that's also true. So that's why that's a yes. The next one, 2, 0. So let's plug that in. We got 0 for y. 0 is greater than 2 times 2 plus 1. So that's 0 is greater than or equal to 5. That is false. So that one, you know right away is false. And then the next one, we'll plug it in. So we've got 5 is greater than or equal to 2 times -1 plus 1. So that's 5 is greater than or equal to -1. And that's true. So now we have to test the second one. And that is 5 is less than -1 plus 4. And this is 5 is less than 5. And man, it's so close, but it's false because 5 is not less than 5. It's less than or equal to 5, but it's not less than 5. So anytime you get a false on any of these, they're not solutions to the system. If you get 2 trues, then yes, it's a solution to the system. Okay, let's look at the next one. Graph this inequality. So we're going to graph each of these. I'm going to graph this one in blue. I'm going to set up a table. We're going to find the intercepts. So when x is 0, we get 12y equals 24. Just so I can graph the line, I'm going to change it to an equals. So that's 2. And then if y is 0, we get 8x equals 24. So that's going to be 3. So for this line, it's going to be over 0 up 2, over 3 up 0. And then it's going to be a dotted line because it's less than. And so I'm just going to give, let's see, a dotted line like so. And there we go. Okay, so that one, and I'm not sure on the shading yet, so I'm just going to leave it, okay? Let's do the other one in red. So let me make an XY table for that. Actually, you know what, let's finish out the blue one. Let's figure out the shading. So I'm going to test 0, 0 for the shading. So it's going to be 8 times 0 plus 12 times 0 is less than 24. So that's 0 is less than 24. That's true. So that means I'm going to shade below. So let me grab my blue shader, and we're going to shade everything below that line. And remember, I just chose 0, 0 because it's easy to plug in. You could pick any point that you wanted. Okay, let's slide back over to the second equation. And so if x is 0, that means I get -2y equals -26. So that's going to be 13. And then if y is 0, we get 6x equals -26. And let's see, that's going to be, we can divide by 6. We get x equals -26 over 6, which is -13 over 3, which is -4 1/3. Okay, so let's graph these intercepts. It's going to be a little bit tricky because it's not a nice whole number. So let's see, -4 1/3 is right about there. And 13 is, let's see, 11, 12, 13 is like right there. And this one's going to be a solid line. So let's do that. And then let's test 0, 0 on that one to see if that also works for the shading. And if so, then we'll shade that area. So I'm just going to do it down here. Is 6 times 0 minus 2 times 0 less than or equal to negative 26? So is 0 less than or equal to negative 26? No, it's not. That's false. 0 is bigger than negative 26. So that means I'm not going to shade 0, 0. I'm going to shade away from that. So I'm going to shade this area. So where's my solution? My solution is this shaded overlap section right here. These are all the possible correct answers to this system of inequalities. Okay, and the last one, let's look at this. And yeah, it may look a little bit ugly, but I just want to show you that you can do this with multiple inequalities. So let's do the first one using our black. So I'm going to graph the intercepts. When x is 0, that means we get negative 6y equals 36. Divide by negative 6, and we get negative 6. And then if y is 0, we get 9x equals 36. So then divide by 9, and we get 4. So 0, negative 6. 1, 2, 3, 4, 5, negative 6. And then 4. This is going to be a solid line because it's less than or equal to. And then let's test 0, 0. So I'll test it right below here. We've got 9 times 0 minus 6 times 0 is less than or equal to 36. It's a strange 3. So we get 0 is less than or equal to 36. That's true. So let's shade that area. So we're going to shade 0, 0, which means we're going to be shading above this line. All right, so there's our first one, and I can shade more later if I need to. Let's do the next one in red. So we will make an XY table. If x is 0, we get 8y equals 16, so that means y would be 2. If y is 0, then we get 4x equals 16, and divide by 4, we get 4. So 0, 2, 4, 0, that's kind of convenient. They are at the same spot. This is going to be a dotted line. Because it's just greater than, not greater than or equal to. And then let's test 0, 0 for this one as well. So we would have 4 times 0 plus 8 times 0 is greater than negative 16. So is 0 greater than negative 16? Sure. So we're going to shade 0, 0, which means we're going to shade below the red line. All right, well, we're not quite done yet because we have to shade a couple more regions here. Let's see, we've got, well, x is greater than 0, so that means we're going to, hold up, I think I made a mistake here, I'm sorry. Let me undo some stuff. Made a little mistake on my graph. Sorry about that. Okay, so let's back up here. I made a little mistake when I forgot to do negative. I didn't pay attention to that negative sign, so that's going to change the signs on these. We're going to have 0, negative 2, and negative 4, 0. My apologies on that. All right, so now we can graph this one. This is going to be a dotted line. And then when we test 0, 0, like we just did, that actually, I did that correctly. So 4 times 0 plus 8 times 0 is greater than negative 16. 0 is greater than negative 16. So we would indeed shade above this line. So sorry about that mix-up there. Now let's talk about x is greater than or equal to 0. That's going to be a vertical line, and it's going to hug the y-axis. So greater than or equal to is going to be shading to the right. It's going to be bigger than or equal to x. And then the y is less than or equal to 0, we'll do in green. And that's going to be a horizontal line where y is 0, so like right there. We're going to do less than, so that means we're going to shade below. And so we need to find where is the overlapping section where all 4 of these overlap. And it might be tough to see, but hopefully you kept track of this as we were doing this. And so I'm just going to color it in yellow, and it's this little region right here. So any points in here in this yellow shaded part will work for all 4 of these inequalities. All right, so that is systems of linear inequalities.